Welcome to the second part of the Kubeflow training and AutoML summit. So the next session will be about project updates and Q&A. So the first thing before we jump to the project updates, I just want to say that in the Q&A session, we will have like a live discussion with our users. So if you have any questions regarding to training, AutoML, or Kubeflow in general, you can just leave your questions in this doc. I will share the link again with you in the Zoom chat. So during our session, we will ask the questions, and to make sure that if you have any like feature proposal, or if something is not clear to you, please feel free to update the document in the doc. And you can also like post your questions in the Zoom chat, and we will try to answer them in an appropriate way. Okay, let me actually start with sharing my screen. Great. So can you see my screen?
Yes.
Okay,
yes.
Great. Yeah, so I'm Andrey, by the way. I'm like because I haven't like given an introduction. I'm Andrey. I'm the AutoML and training working group technical lead. And we're here with Johnu. Johnu can also give you an introduction.
Yeah, hi everyone. I'm Johnu. I'm a staff engineer in Nutanix. I'm also leading the AutoML and the training working group.
Yeah, so first of all, we'll give a bit about the training. So Johnu, you can step forward and give an update about the training part.
Great. So hi everyone. Great to see you all again in the second session. So we'll start with the project updates. So I'll start with the training one, and Andrey will talk about the Katib updates. So in training, the biggest change that is happening right now is with respect to all-in-one operator. So I'll just give a brief context, and Jashin will talk more about the details in one of the upcoming sessions. So here, like 3 years ago, when operators were started, the TF operator was the very initial one, and it was one of the very earliest project in Kubeflow. So when it had the first V1 Alpha 1 release, there were efforts to bring in more operators to Kubeflow. And that is where when we started the PyTorch operator, and it had V1 Alpha 1 release. And then we figured out that there were lots of common code across operators. So that is when a new effort was started to separate out the common code and the operator specific code, which is the basis of the current the operator design. So you could see that there is a Kubeflow/common repository, which contains the common operator code, while the operator specific code lies in the TF operator, PyTorch operator repositories. Then what happened was there were huge rush of new operators. Then XGBoost, MXNet, MPI operators came into picture, and there are more operators right now getting added. You would have actually seen the paddle operator and the DGL. Now, so the biggest problem is there is increased maintenance, and we are finding it difficult to do the recess because there are too many repositories now, and that even the testing effort is getting difficult, which is kind of split across different repositories. So we have started a new effort here to have all-in-one operator. So we haven't fixed on to the name. Say that would be the Kubeflow training operator, which we can consider that is the single operator which would handle training of all frameworks. So yeah, basically it will be an installation of just one operator in your Kubeflow installation. So that is a work which is ongoing, and that is one of the very big change which is happening. And most of the issues are that we are tracking now, it's related to that. So here, if you see that the one would be like getting in common CI/CD infra for having this. So we would try to merge all the testing code and the infra which lies in different repositories to the common one, and try to do that in a single repository. Then we need to have a generic Prometheus metric collector. Right now, each training operator has its own metric collection. So all this would actually help in keeping a common maintainable code than going and fixing the same issue in multiple repositories. Then we are planning to add a separate dashboard for operators, which would include again like kind of common way of applying different operators. Say if it is a TensorFlow or PyTorch operator, it would be a single dashboard, and the all-in-one operator will take care of it. And also together with that, we are planning better GitOps, and this is one of the major asks from users, where a data scientist doesn't want to understand how to build their user code. They just have a Python file or a GitHub repository. So we are trying to figure out what is a better way to do that by just pointing to a GitHub repository, and automatically the container is built and the training is started. So that would be possible once all-in-one operator is fully merged and tested well. So in common operator, one last feature that we are planning is the dynamic volume provisioning. So that is one proposal which is already raised, which basically the proposal is about having a common scratch space across the worker pods, which is persistent across restarts, but will get deleted once the training is done. So it would serve kind of like a temporary workspace for different workers. And for operator specific features, once we have the all-in-one operator, we will try to have a common pipeline launcher. Right now we have a TF launcher, PyTorch operator, PyTorch launcher as a separate component in Kubeflow pipelines. So we will try to have like a common launcher for all the training jobs. So that way, again, the code maintenance and from the user point of view, it will be much more easier. There's a separate proposal for MBA operator for better scalability. So right now they use the kubectl exec for launching the worker scripts. We are trying to figure out what is a better way by moving to the SSH way of doing that instead of overloading the API server. So you can take a look at that. So those are the things right now which we have in the current roadmap. So the bigger change, or the main thing that we are focusing on the upcoming release is the all-in-one operator, which will make it really easy. Yeah.
Okay. Can we move forward, Johnu?
Yes. Go ahead.
Yeah, sure. I will give you an update about the KDIP perspective. So the first thing, which you already seen in this summit before with a great session from Kamenos, we will definitely integrate completely new UI. And this will be the part of the Kubeflow 1.4 release. So in the Kubeflow 1.4, we are planning to have the a new UI as a default image. And all of our users in the Kubeflow installation, they will see completely new dashboard from the KDIP perspective. And we are trying to merge all of the features as soon as possible and as a new one. So it is very important to always give a feedback about our UI to make it very clear for our users with the best user experience. And this integration is ongoing. If you just want to learn more about this part of the integration, you can just follow up the project in our repo that I shared before. So a couple of things from the AutoML perspective and the KDIP. So eventually originally KDIP was designed in 2018 as the hyperparameter tuning on top of the Kubeflow. But currently we're trying to build a cloud native framework for AutoML. So we have a couple of algorithms which KDIP already supports, which includes Bayesian optimization, hyperband, covariance matrix adaptation, quasi-random, and some other like famous algorithm. But of course, we continually looking for and researching the newest framework, which is popular use across the MLOps community. And especially we try to even more like support the SCHA, which is basically asynchronous successful halving algorithm, which is currently very popular in the hyperparameter tuning algorithms. And in the meantime, even in a 1.4 release of Kubeflow, we'll integrate Sobol algorithm, which is part of the GoPtuna framework. And in the meantime, we supporting new IPOP and BIOP overstar strategies. You can learn more about it just clicking the issue which we posted here. And in the meantime, that I mentioned that we're trying to make KDIP not only for hyperparameter tuning, but at the same time for AutoML. So currently we supporting a neural architecture search and hyperparameter tuning. But also we're trying to support some also fancy AutoML features such as feature engineering and model compression and like population-based training. So this, as we discussed before in our sessions, this can be done as part of the other frameworks. For example, we can use like pedal functionality to make sure how we can integrate this AutoML techniques in the Kubeflow, because this is also like very useful for our Kubeflow users and how they can use it. You can also like follow them. If you're like interested in the implementation of one of these algorithms, please let us know in the issue that they posted here. And speaking about like the components enhancement, we also like continually working on a couple of enhancements there. And as we mentioned before, currently KDIP supports dynamically support any type of the Kubernetes CRD. So eventually you can use KDIP as the orchestrator on top of your Tecton pipeline, on top of your Kubeflow pipeline, on top of your Argo workflow. And in the meantime, you can use like any other distributed operator which Kubeflow provides, such as TensorFlow, PyTorch, MPI, MXNet. And we try to make it as easier as possible. And we create a couple of guidelines how a user can integrate their own CRD in KDIP. So currently they don't really need to modify the source code. They can just dynamically update the controller functionality and support completely new framework. Even this CR can be internal in your company. And if you don't want to actually share it, you can just take the KDIP controller source code, extend it with your custom operator, and use it and use the KDIP on top of your distributed training operator, for example. And in the 1.4 of Kubeflow release, we're planning to support Argo workflow in upstream and also XGBoost job, which is part of the Kubeflow. So also, which is really important, we want to support push-based metrics because currently KDIP uses pool-based metrics collector, which is eventually just a sidecar container on top of your training job. And this is not, in some use cases, this cannot be useful for you. Because imagine if you have like around thousands or maybe 10 of thousands of pods, and you need to inject our metrics collector on all of these pods. For some cases, it can be not usable for your environment. And for that case, we want to extend our SDK to support the functionalities to directly push metrics from your training container code directly to the KDIP DB, which can be anything. So currently we supporting MySQL and upstream, but we have the DB manager where you can integrate your custom DB such as MongoDB, Postgres, or any sort of the volume that you want to use. And in the meantime, we're trying to make some improvements in parameter distribution, such as log uniform, because all of the framework that we're using for hyperparameter, they supporting a couple of different distributions. And for example, like HyperOpt, you can specify parameter distributions there, and we try to implement it in the API. And also, like, we're trying to improve hyperband in test and release infrastructure, which should make it easier for our users to deploy KDIP in their infrastructure. Yeah, so sorry. Okay, let me. Yeah, and because this is the session about like AutoML and training, I just want to give the quick community updates. So first of all, just you can check the meeting notes, and we have our working groups meetings every Wednesday. So our working groups meetings happening 2 times in a month, and you can check these meeting notes to attend these meetings. And also, you can check our recordings on YouTube. You can check our Slack channels. You can also check our adopters list. That you, if you're just using KDIP or using the training operators, please feel free to let us know and update the adopters list. And if you want to contribute in Kubeflow, please check the developer guide, help wanted issues, and if you want to have any new features, please submit the proposal. Also, you can feel free to check the roadmaps with the same items for KDIP or training operators that Johnu mentioned before. Yeah, and I think we can move forward to the Q&A session. Let me first of all check the questions in the chat. Yeah, I see a couple of questions from our users. So yeah, so I think first of all, let me actually ask the questions from the Zoom chat about the volume up. So the question was, I don't know, do you want to actually unmute yourself and just give a, just tell about this question more? About the dynamic volume provisioning.
Yeah, so the requirement is not set yet, but here the main idea is to have like a scratch space which would be limited to the life cycle of a training job. So start creating a PVC kind of stuff once the training starts. Does the processing once the training is completed, you don't need the PVC anymore. So that is the whole point. So I have shared the proposal there. You could take a look at that. Yeah.
Does it answer your question, Kemchan? And sorry if I don't pronounce your name correctly. Okay, sounds great. Yeah, let's just move forward to the question. So the first question that was about the Kale, right? So I think this question was from, I'm not sure that, yeah, it's maybe the guy just not in the meeting right now. But the question was about the what is the difference between Kale and hyperparameter tuning, right? So I think Kale, it's more like a tool to automate your Kubeflow pipelines job. So eventually, this is kind of different thing. So Kale is just built on top of the KDIP, and the functionality that Kale provides are completely different than the functionalities KDIP provides. And it's more like the additional tool that you can use from your notebook to be able to not building the container images. Moreover, we're trying to integrate this functionality directly to the SDK to make sure that our users, as Johnu mentioned before, to make sure that our users can build the container images without interacting with the Docker, building the container images without interacting with the Docker. So they can directly tune their parameters using our SDK, or they can directly like train, make distributive training without interacting with Docker. Yeah, so this is our next step. Johnu, do you want to add something here?
Go ahead. Yeah, I'll take the next one.
Yeah, so let's maybe first of all ask the user's question. So the question number 7 was about the hyperparameter tuning. Yeah, let me. So do you want to actually step forward and just say what is the question about?
So we can read that. So so he wants to do hyperparameter tuning for mask RCN and GitHub repo using KTIP. I have a custom dataset and Jupyter notebook which runs and trains my data locally. How do I start KTIP taking and train MRC? Yeah, so so one thing that you can do is KTIP has an SDK, Python SDK. So which means from your KTIP notebook, you could actually invoke KTIP SDK to start the tuning process. And once you have put your training code inside a Docker container, KTIP can take care of the rest of the stuff. So we have similar examples in notebooks. I think it's in the Kubeflow, the main repository, not in the KTIP repository. So we yeah, Andrey, can you just share that?
Yeah, sure, exactly. And I think we're trying to merge all of these examples to KDIP repository. So yeah, I think, let me check first of all. I think we have a couple of notebook examples here. So this is how you can use the KDIP SDK.
So that would be a good starting point for you to use KTIP SDK to invoke the fine tuning process once you have built the training code.
Yeah, exactly. So we're trying to make it as easier as possible to submit the hyperparameter tuning directly from your notebook. So we continually improve our SDK, and if you have a use case where our SDK is not supporting, please let us know. Yeah, does it answer your question, or do you want to add something else about it? Okay, sounds great. I think we can move forward. So the next question about like on-prem installation, right?
So there are lots of challenges during on-prem installation in people community as well. Yeah, so we would really like to know more about the challenges that you are facing. So Ktib can be run as a standalone app in any Kubernetes installation. So it doesn't mandate any prerequisite. Kubeflow installation is like an optional thing that you can do. So we really want to see what are the problems that you are facing, and we will try to resolve that, like in community if you are facing anything.
Yes, can we please create an issue to track what is the problems with the on-prem? And because we're using Ktib in on-prem in production in some environment that I know we have some use cases, and it would be great if we can just track their because there are I know that there might be an issue with the volume setup, and we really want to hear what kind of tutorials I'm missing there.
Right.
Yeah. So the next thing about creating a Ktib experiment, okay. Manish, you can tell about this question if you want. You can unmute yourself.
I'll post the details later.
Okay.
So yeah, so creating Ktib experiments, if it is available to hard to test, right? User should create resources actually in Kubeflow cluster to check availability. Is there a simple way to simple? Do you have any recommendations how we can simplify the process? Here, right now, if, there are manifests in Ktib repository, which you can just do kubectl apply. And ideally, there should not be any other prerequisite other than having a storage configuration already set up for PVC. Other than that, you should not be having any other issue. So if you have any specific recommendation to simplify, we are happy to hear that. But what you have to do is just a kubectl apply manifest, which is provided in Ktib repository, and you should be able to run any example, a Ktib example, either from the Jupyter notebook or from the Ktib examples repository.
Yeah, just to add here, I had a couple of requests that it can be hard to actually getting started with the Kubernetes installation part. We'll probably create a couple of examples how you can get started with one single command with, for example, like your local machine without any sort of the Kubernetes clusters with a kind, for example, cluster. And then how you can simply run the experiments on your local machine without interacting the Kubernetes, I don't know, GCP or EKS or any on-prem cluster. Does it help to you if we have some sort of these examples, how to get started with your local machine with the one command? What do you think? Yeah, I think we can maybe follow up because the questions here, we received also the feedback from the community meetings that it's like, usually it can be hard to getting started if you don't know what is Kubernetes and how you can run the resources there. But overall, definitely, if you have any questions to the documentation side, please feel free to open an issue under the Ktib repository. Yeah, should we move forward? So the next question is about Istio sidecar. Yeah, I think I can actually answer this question. So the problem is with the Istio sidecar, it's because of our Docker images. And for some cases, almost in all our examples, we upload the dataset from the public repositories and from the public places. And the Istio sidecar proxy for some cases can block some sort of the connections, and we cannot just run our examples on the public cloud. But if you have your own training container source code, and if you optimize your dataset uploading, for example, using like PVC to provision your dataset on your training on your trial pod, you can definitely use Istio sidecar. Yeah, so this is not the requirements from the Ktib perspective. This is more like from the training job perspective on the cluster. Okay, sounds good. Yeah, so yeah, then I think we can move forward to John. Do you want to take the next question?
Right. So with respect to memory request and limit, CPU request and limit for every container. Okay, so how Cative works is, so so there is a container in Kubeflow pipelines which is spawned, which will launch Cative job from that container. So the Cative job remains the same. So you could control all the memory resources and the CPU resources from the of Cative, because effectively, essentially, the trial pod is providing a pod template, so you could control how many resources Cative job is using by providing the CPU limits and the memory requirements in the pod template spec. So there is, I think in the example that we have provided, Cative doesn't provide that. Do we have an example there? But finally, end of it, it's a pod template spec. You could add your resource limits in that itself.
This is in general Kubeflow question for the pipelines, not related to the Cative.
I think you can use resource and limits, as John mentioned, in your template in the YAML. So eventually, which kind of the Kubernetes CR are you using? Are you using like Kubernetes job as to perform your training, or are you using the which kind of pipeline you have?
So say if we create a pipeline, we create different containers for our pipeline using that component spec, that component.yaml file that we usually give, right?
Okay.
Yeah. So for each for that component, a corresponding container got created, right, in the when we run that pipeline. So how to specify how much memory that container will live? On the component.spec, on the component.yaml, we have only, like, we can provide the image, the command, and the arguments. But where do we actually specify that resources? How much resources corresponding to that component that container will take?
Yeah, I think okay, so that is slightly out of scope, but we'll just get back to that. Yeah, we'll ask the pipelines team how we can do that. I'm sure there was a configuration to do that. I'll ask the pipelines team and get back to you regarding that. If you can create a issue in Kubeflow pipelines, that would be better to track.
Yeah, and even more, I think in our today's example from Aniruddha, like from the pipelines that he provided, they have like the resource function there that he specified for the components. So it might be worth to just take a look just on their presentation before, a couple of hours on the recordings, and to see how he specified the resource requirements for the pipelines components. Okay, sounds great. So I know we don't have like much time, but some couple of questions to the community. So it's about like difficulty to use training operators. So can you give any feedback? Is it hard to getting started with Cative or training operators? What do you want to see from us, from the contributors, how we can improve this sort of the getting started guides?
So if we get some possible recommendations or some feedback, it would be really helpful. If you have even something to talk about, like you could even create an issue and then we can track in that too.
Yeah, I would also like recommend, because I was speaking about like supporting algorithms or supporting different frameworks. Please let us know like which use cases. We definitely will discuss about it in the panel again with Josh. But if you have any algorithms that you want to use and Cative currently doesn't support it, please let us know. You can also like comment. If you don't want to create an issue, you can comment it here in this doc, because you should have like the comment access. And this is about like the algorithms which won't support the examples that are missing. So as we said before, for example, we're missing like the getting started example with the local machine with the kind cluster. And in the meantime, about using like the custom CRD and like the Kale config.